Have you ever faced a situation where your model's performance is hindered by masked tensors? It can be quite perplexing, right? If that's you, then you're in the right place. Today, we're diving into how to compute cross-entropy loss with masked tensors. I understand how frustrating it can be when your model's predictions are affected by masked values. You're not alone in this struggle. Many developers encounter this issue when working with logits and labels. Here's the specific question we're addressing. One user asked, how do I compute cross-entropy loss between logits and corresponding labels when some values are masked? They provided examples of logits and labels, highlighting the masked values. Sound familiar? Let's explore this together. So what's the challenge here? The issue arises because softmax followed by log will include the masked zeros, which we want to avoid. We need a method to compute the loss while ignoring these masked values. Let's break it down step by step. And stay tuned. I have a crucial tip at the end that will help you handle masked tensors effectively in your models. To compute the cross-entropy loss while ignoring the masked elements, the user should first apply the softmax function to the logits. This will convert the logits into probabilities. Next, the user should create a mask that identifies which elements are valid for loss computation. This mask will be based on the labels, where a value of 1 indicates a valid element. Now, the user can compute the cross-entropy loss. This involves taking the negative log of the probabilities for the valid elements multiplied by the corresponding labels. Finally, the user should ensure that the loss is averaged only over the valid elements. This will give the correct loss value while ignoring the masked zeros. Fun fact, the concept of masking in machine learning is similar to putting a blindfold on during a game of hide and seek. You want to focus on what matters and ignore the distractions. Now let's look at the answers provided by other users. An alternative approach shared by a user involves using TensorFlow to handle masked tensors. They create a mask to identify valid logits and replace masked values with a large negative number. This ensures that the softmax function only considers the unmasked logits. The user provides a code snippet that demonstrates this method. They initialize the logits and the mask, then use TensorFlow's where function to apply the mask. Finally, they compute the softmax of the resulting scores. That wraps up that answer. Let's move on to another one. An alternative solution provided by a user involves using TensorFlow to compute the cross-entropy loss. They suggest importing TensorFlow and defining your logits and labels as shown. Then you can calculate the loss using the softmax cross-entropy function, which effectively handles the masked values. Let's check out another perspective from a different user. An alternative solution from a user suggests using indexing with TensorFlow 2. They recommend creating a mask to identify non-zero logits. Then they cast the mask and labels to float 32. Finally, they compute the softmax cross-entropy loss using only the masked elements. Here's the crucial tip I promised. Always ensure your masking logic is correctly implemented to avoid unintended consequences in your model's performance. And there you have it. You should now be able to compute cross-entropy loss effectively with masked tensors. Remember, mastering this technique can significantly improve your model's accuracy. If you found this helpful, hit the subscribe button for more insights, and don't miss our next video on advanced tensor operations.